Hi class, welcome to our first video lesson of Chapter 9. We're on 9-1, Reflections. A reflection is a flip of a figure over a point, a line, or a plane. Oftentimes it's a line. It isn't always a line, but in our units several times we flip a figure over a line. This very first slide that I had, this magnifying glass is a reflection. This is flipped over this line right here. So that's a reflection. It's a flip of a figure over a point, line, or plane. When it's over a line, we call that line of reflection the line which the figure is reflected about. So our line of reflection is this line right here in this first example. Okay? So that's our line of reflection, a line which a figure is reflected. Isometry is a congruent transformation. And that's what we're going to be talking about today. All the shapes that we're going to be reflecting, they're not going to get any bigger or any smaller. They're going to stay the exact same size. Such as this magnifying glass right here, it's a congruent transformation. It didn't get any bigger from the pre-image to the image and vice versa. So it is a congruent transformation. We call that isometry. All right, so here's the first one. We're going to reflect this triangle over the y-axis. So you see the y-axis, it's right here. It's the line that goes up and down. It's a vertical line. And we want to reflect it. So when we reflect it, what's going to happen is this point, -2, -1, is 2 units to the left of the y-axis. So when we reflect it, when we flip it, it's going to be 2 units to the right. That makes sense, right? And this point right here, if it's left 1, 2, 3, 4, 5, up 3, then we're going to, if it's 5 units to the left of the y-axis, when we flip it, it's going to be 5 units to the right. 1, 2, 3, 4, 5. So it's going to be right there. And this -3, up 7, this one right here is 3 units away from the y-axis. So when we flip it, it's going to be 3 units to the right of the y-axis. And here is our image. We call this triangle the pre-image. It's where we started. The image, that is like the reflection, that's where we end up. So we end up, instead of left 3 up 7, we go right 3 up 7. That's where our image is. And so now this -5 up 3, we end up at right 5 up 3. And when we went left 2 up 1, when we reflected over the y-axis, we ended up at right 2 up 1. All right, class, question for you. What happened to each and every one of these ordered pairs? Notice how the x-coordinate switched signs. The y-coordinate stayed the same. And that's going to remain true whenever we reflect a point over the y-axis. What's going to happen is the x-coordinate is going to change sign. So we would say that it's now a -x. It doesn't mean that it's going to make the x-coordinate negative. This -x means that it changes the sign. And then we're going to keep the y-coordinate exactly what it is. It doesn't mean that the y-coordinate is always going to be positive. It just means that the y-coordinate is going to stay the exact same sign. So when we say -x, positive y, we're going to say that from pre-image to image, the -x means that the x-coordinate changes sign. The y-coordinate stays the exact same. So once again, the pre-image is where we're starting. After we reflect the figure, that's what we call the image. So here I have a practice problem here for you. This right here is the pre-image. And for our pre-image, when we reflect it over the y-axis, if it's a point xy, it turns into -xy. So I want you to pause the video and I want you to reflect these 3 points over the y-axis. Okay, after you did that, you changed the sign on the x-coordinate and you stayed the y the same. So a -4, +5. For our next one, you should have had a different sign on the -2, so you switched the sign to make it +2, -3. And then you should have changed the sign on the x-coordinate, kept the y the same, to make it +1, +8. That's how you reflect that over the y-axis. Let's see now about the x-axis. So with the x-axis being the horizontal line, this one right here, right? If I want to reflect or flip this over the x-axis, right now I'm 1 unit above the x-axis, so I want to go 1 unit below. On negative 5 up 3, I'm 3 units above, so I'm going to go 3 units below. And for this negative 3, 7, I'm 7 units above, so I want to go 1, 2, 3, 4, 5, 6, 7 units below. And here is my image. The triangle is the exact same size, so it's isometry. It's a congruent transformation. But what happened to all of my points? Instead of left 2 up 1, I'm at left 2 down 1. Instead of at left 3 up 7, I'm at left 3 down 7. Left 3 down 7. Instead of at left 5 up 3, I'm at left 5 down 3. So on all of these pre-image to image transformations, what happened to all my points? The x-coordinate stayed the same on all of them, right? The y-coordinate changed its sign. It was 7, negative 7. It was 3, now it's negative 3. It was 1, now it's negative 1. So the x-coordinate this time stays the same. The y-coordinate changes its sign. That's what negative y means. It doesn't mean that the y-coordinate is always going to be negative. It just means that whatever the y-coordinate was, we're going to change the sign. So you guys pause the video, please. Try this one when we reflect over the x-axis, which means for every point x, y, it results in a, what did we just say? X negative y. X negative y. So pause the video, try that on your own. All right, after you did that, you kept 4 the same, but you changed 5 to a negative 5. 4, negative 5. Negative 2 stayed the same, and you changed negative 3 to a positive 3. So negative 2, positive 3. And then negative 1, positive 8. You kept the negative 1, and you changed the sign on the y, so a negative 8. Negative 1, negative 8. All right, we have 3 more reflections. This one is over the line y equals x. I'll just tell you the congruent transformation or how you change it right now. When it's over the line y equals x, this line right here, that's the reflection line. What happens is that the y's and the x's change spots. So the y-coordinate becomes the x-coordinate, and the x-coordinate becomes the y-coordinate. So from our pre-image to our image, it's going to be 7, negative 3. It's going to be 3, negative 5. Your x and y switch. It's going to be 1, negative 2. Notice what that looks like on the graph. If I go right, 1, 2, 3, 4, 5, 6, 7, down 3. If I go 3, down 5. And if I go right 1, down 2. What I kind of look at this as sometimes, class, is if I fold this graph paper over the reflection line, notice how the 2 triangles would land right on top of each other. Almost picture visually in your head folding this over the dotted line right here. And when you fold it, those 2 triangles would land right on top of each other. Okay? So whenever we reflect over the line y equals x, what we do is we change the ordered pairs around. So you guys pause the video. When we reflect over the line y equals x, for every point x, y, the image goes y, x. Pause the video, try that one. All right, after you tried it, instead of 4, 5, you got 5, 4. Instead of negative 2, negative 3, you got negative 3, negative 2. Instead of negative 1, 8, it's 8, negative 1. Okay? All right, for the next one, it's over the line y equals a negative x. So for the line y equals a negative x, now our reflection is this line. Okay? So I'll tell you what that transformation looks like. For every point x, y, what happens when we reflect over the line y equals a negative x is it turns to a negative y, negative x. So not only do the x and y coordinates change spots, but you also change the sign on each x and y coordinate. So for our pre-image to our image, this 7 goes to the x-coordinate and it changes its sign. This x goes to the y-coordinate and it changes its sign. So negative 7, positive 3. Let's see what that looks like. Negative 1, 2, 3, 4, 5, 6, 7, up 1, 2, 3. There's our image for negative 3, 7. Negative 5 up 3, we're going to change the spots and change the sign, so it's negative 3, 5. And then for negative 2, 1, it becomes negative 1, positive 2. Let's put these points on the graph as well. Left 1, 2, 3, up 1, 2, 3, 4, 5, and left 1, up 2. Now this might look kind of fishy right now, but I want you to try to mentally fold this piece of paper, fold this graph visually over the line y equals negative x. Picture this as being the crease in the piece of paper, right? These 2 points would land right on top of each other when you folded it. These 2 would land right on top of each other when you folded it. These 2 would land right on top of each other when you fold it. So when you reflect a figure over the line y equals a negative x, here's what happens. The ordered pairs change their sign and they change their spot. The x goes to the y coordinate, the y goes to the x coordinate. Hoofda! All right, you guys try this one over the line y equals a negative x. So for every point x, y for our pre-image, the image turns into a negative y, negative x. Pause the video, try that one. All right, you switch these 2 around, so 5, 4, but you also change their sign. So a negative 5, negative 4. Boom cha. For the next one, negative 2, negative 3, you switch their sign and switch the sign and switch the ordered pair, so it's a positive 3, positive 2. And now this one, negative 8, positive 1. All right, we got one more reflection. This time we reflected about a point. The origin right here, this is our first one where we're not reflecting it about a line, we're reflecting it about a point. So that point right there, we want this to be on the other side. And this to be on the other side. We're reflecting it over here. And then this one to be on the other side, so it's going to be over here. I'll tell you how that works as I have the past few examples. For every point x, y, what happens is we're going to keep x and y in the same spots, but this time we change the signs on both of them. So it's a negative x, negative y. So we're going to keep the ordered pair in their same spots, just change their signs to get our image. So it's going to be a positive 3, negative 7. It's going to be a positive 5, negative 3. And it's going to be a positive 2, negative 1. Let's see how that looks. Right 3, down 7 is right there. Right 5, down 3. And then right 2, down 1. Here is our image. Again, it's a congruent transformation. The triangle didn't change size at all. It's still the exact same size. But all of those points are reflected about the origin, about that point. So you guys try this last one on your own as well. For every point x, y, you keep x and y in their same spots, except you change the signs on both of them. Okay? So try that on your own. After you tried it, you got a negative 4, negative 5, a positive 2, positive 3, a positive 1, negative 8. All right, on to something different. I hope that makes sense. For lines of symmetry, again, what is a line of symmetry? It's where you can fold the figure exactly in half. What I think of it as, it's like the crease in a piece of paper when you fold it. Okay? So how many lines of symmetry does the letter F have? Sometimes our alphabet can have lines of symmetry. The capital A, for example, if you fold it right down the center, it's the same on the left side as it is on the right side. You could fold it exactly in half. For the letter F, there's no way that you could really fold this so that the left and the right sides are exactly the same, right? It's just impossible to do that. So how many lines of symmetry does the letter F have? It doesn't have any. It has 0. How about this triangle? I could fold it once right there, and I could fold it exactly in half. But just once. I can't fold it this direction, or I can't fold it this direction. So the isosceles triangle just has one line of symmetry. How about the rectangle? Well, I think everyone sees we could probably fold it right here, and there's one line of symmetry. I think people see that we could fold it once right here. There's 2 lines of symmetry. Can we fold it along the diagonals? If you fold it this way, one diagonal does create 2 congruent triangles, but that isn't a line of symmetry because the left and right sides are not exactly the same when you fold it. So this one just has 2 lines of symmetry. The equilateral triangle has 3. once right here that cuts it in half, and once right here that cuts it in half, and once right here that cuts it in half. So those are the three lines of symmetry. The square does have 4 lines of symmetry. That is the vertical crease, the horizontal crease. You could also fold it along the diagonals on both sides. So this one has 4 lines of symmetry. And the star, technically speaking, a decagon because it has 10 sides. You could fold it once right there, and that cuts it in half. Once right there, that cuts it in half. There's 2. 3 times, and 4 times, and 5 times. This can be folded 5 different directions, and it cuts it in half. All right, there's lines of symmetry. Last slide is point symmetry. Point symmetry is a common point of reflection, or the center of the figure. Remember how we reflected a figure over the origin? Very similar, we reflected it about a point, so the origin was the point of symmetry. So this point of symmetry right here, this point on this part of the figure is going to be reflected right through the point of symmetry to the other side, and it's congruent on the other side, or it's the same spot. Same thing for this one. It's being reflected right through this point and over here. This one would be reflected over to here. This one would be reflected over to here. Okay? That's point symmetry. All of these figures have point symmetry. This point is reflected through the middle right over to here. So it's the center of the figure is what point symmetry is. All right, do these figures have point symmetry? Does the letter B have point symmetry? Well, if we figure the center of the figure being right here, does this point look exactly the same on the other side? Is it the same thing over here? No, we have a 90-degree angle right here, so we would have to have a 90-degree angle over here, which we don't. So the letter B does not. How about the hexagon? Here's a point. Is this angle the same on the other side of the figure? Yes, it is. Same as this one here. When you, on the other side of the figure, it's right here. This one does have point symmetry. How about the letter H? The letter H does. This 90-degree angle is the same as it is over here. This one right here, this point, is the same as this point over here. So the H also has point symmetry. Hopefully that video lesson made sense, especially when you have to reflect a figure over a line, the x-axis, y-axis, y equals x, y equals a negative x. Those are big concepts. Let me know if you have questions on those when you get to class tomorrow.